Have a great day, everyone, and welcome again to Fun with Maths. Here's another problem. 256 to the power of m plus 256 to the power of m plus 16 to the power of m is equal to 1. Find the value of m. Here's the solution. First, let's bring down the given equation. Next is, for our base, we have base of 256, another is 256, and another is 16. What we can do is, we are going to write it into a power form with the base of 16. So for 256, we can write it as 16 squared, because 16 squared is equal to 256. Then whole to the power of m. Then plus, same 256, so that is 16 squared, then whole to the power of m. Plus 16 to the power of m, we just need to copy. So 16 to the power of m equals 1. Next is, we can interchange the power by following this rule of a power. A to the power of x whole to the power of y is also equal to a to the power of y whole to the power of x. So this is now 16 to the power of m whole to the power of 2 plus 16 to the power of m whole to the power of 2 plus 16 to the power of m equals 1. Next is, we can let 16 to the power of m be equal to n. So for this to write, that is now n squared plus n squared plus n equals 1. And then combining like terms, n squared plus n squared, that is 2n squared plus n equals 1. Next is, we can apply the grouping and factoring. So for grouping, we need to split n into 2n minus n. So this is now 2n squared plus 2n minus n. And then we need to take 1 to the other side. So this is now minus 1, then equal to 0. Next is factoring. Now we need to identify the common in every group. By the way, this is the first group and this is the second group. For the first group, 2n squared plus 2n, the common is 2n. So we write here 2n, then times 2n squared divided by 2n, that is n. And then positive 2n divided by 2n, that is 1. And that is plus 1. Next is, for this group, the common is negative 1. So minus 1 times negative n divided by negative 1, that is n. And then negative 1 divided by negative 1, that is positive or plus 1, equals 0. Now, as you can see, we have a common, which is n plus 1. So we take that out, n plus 1 times the remaining we have 2n minus 1 equals 0. For this, we can have two equations. First equation is n plus 1 is equal to 0, and that is n is equal to negative 1. Another, 2n minus 1 is equal to 0, and that is 2n is equal to positive 1. Divide both sides by 2. This is cancelled, so we're left with n is equal to 1/2. So for now, we have the values of n n is equal to negative 1, and also n is equal to 1 half. Now next is, we need to find the value of m. Now earlier, let's recall that 16 to the power of m is also equal to n. We let this be equal to n. So now we can use this to find the value of m. So 16 to the power of m equals negative 1. For this, since it's negative 1, that means there is no real solution. So this is invalid. Another is 1 half. So 16 to the power of m is equal to 1 half. For this 16, we can write it as 2 to the power of 4, because 2 to the power of 4 is just equal to 16. Then whole to the power of m equals 1 half. Next is power to a power, we can multiply. So that is now 2 to the power of 4 times m, that is 4m, equals, for 1 half, that is equivalent to 2 to the power of negative 1. So now they have the same base, 2 and 2. So we can equate the power, and that is 4m is equal to negative 1. And then we can divide both sides by 4. So this is cancelled. So we have m is equal to negative 1 over 4. This is our final answer. Again, m is equal to negative 1 over 4. Now earlier, I said that negative 1 has no real solution because it's negative. Apart from being negative, from the base 16 and negative 1, it's far different. So that's considered invalid. So that's it. So therefore, 256 to the power of m plus 256 to the power of m plus 16 to the power of m is equal to 1. The value of m is equal to negative 1. The value of m is equal to negative 1 over 4. And that's all for today. For more exciting videos, don't forget to like and subscribe to Fun with Maths.